Hi, everybody. Today, let's join Factory Intelligence as we explore the secret behind the door of one of the largest cigarette factories in the world. According to the Centers for Disease Control and Prevention, an estimated 28.3 million adults in the United States smoke cigarettes, and approximately 2.8 million middle and high school students in the United States use at least one tobacco product. What makes cigarettes so enticing? I'll head to the factory to see how the cigarette making process unfolds. Embark on a discovery quest. Subscribe to Factory Intelligence now. This video discourages cigarette use due to its health risks. History of cigarette's ancient origins. Before the advent of modern cigarettes, plant leaves have been utilized since ancient times. The Maya and Aztec people used them for thousands of years as tobacco leaves. These ancient civilizations would roll tobacco in palm leaves or corn husks, creating early versions of what we know today as cigarettes. Archaeological evidence suggests that tobacco cultivation dates back to 5000 BCE in the Americas. The indigenous peoples didn't just smoke tobacco. They used it in religious ceremonies as medicine and as a form of currency in trade. European discovery. In the 16th century, Europe imported tobacco and introduced it to America through exploration. When Christopher Columbus arrived in the Americas in 1492, he observed native inhabitants smoking rolled tobacco leaves. Initially, European explorers were skeptical, but sailors began adopting the practice during long voyages. Sir Walter Raleigh is often credited with popularizing tobacco smoking in England during the late 1500s. Initially, it was used for medical and recreational purposes. Doctors believed tobacco could cure a variety of ailments, from headaches to cancer. Ironically, the opposite of what we know today, the rise of commercial cigarettes. By the 19th century, cigarettes became a staple in American consumer culture. The Industrial Revolution brought machinery that could mass-produce cigarettes, making them affordable and accessible to the general public. In 1881, James Bonsack invented the cigarette roller machine, which could produce 120,000 cigarettes per day, far surpassing the 3,000 that skilled hand rollers could make. This revolutionized the tobacco industry and led to the birth of major tobacco companies. During World War I and World War II, cigarettes were included in soldiers' rations, which dramatically increased their popularity. By the 1950s, over half of American adults smoked cigarettes regularly. Health revelations. However, scientific research revealed its health hazards, leading to efforts to minimize its usage. In 1964, the U.S. Surgeon General released a landmark report linking cigarette smoking to lung cancer and other serious diseases. This began a decades-long public health campaign to reduce smoking rates. Today, cigarette packages must carry health warnings, and advertising is heavily restricted in most countries. Despite these efforts, cigarettes remain one of the most consumed products worldwide. Production par is how are cigarettes manufactured? The modern cigarette manufacturing process is a marvel of industrial engineering, combining agriculture, chemistry, and advanced automation. Let's explore every step of this fascinating journey. Cultivation and harvesting of tobacco, selecting the perfect location. The journey begins in the flatland area of North Carolina, where springtime is ideal for planting. North Carolina, along with Kentucky, Virginia, and Tennessee, produces over 70% of tobacco in the United States. Tobacco requires specific growing conditions: well-drained soil, warm temperatures between 68 to 86 degrees Fahrenheit, and adequate rainfall. Farmers carefully select fields based on soil pH levels, drainage patterns, and previous crop rotations to ensure optimal growing conditions. Nursery preparation. Skilled workers fill trays with soil in the nursery area. This isn't ordinary soil. It's a specially formulated mixture containing peat moss, vermiculite, and essential nutrients designed to give seedlings the best possible start. Each tray contains hundreds of individual cells, ensuring that each seedling has its own space to develop a strong root system. The soil is sterilized to prevent disease and treated with beneficial microorganisms that promote healthy growth. Seeding process. An automatic seeding machine evenly spreads seeds onto the soil. These machines are precision engineered to place exactly 1 or 2 seeds per cell, ensuring consistent germination rates. Music. Tobacco seeds are incredibly small. About 10,000 seeds weigh only 1 gram. This is why automation is essential. The machine uses vacuum technology or electrostatic charges to pick up individual seeds and place them with perfect accuracy. The trays are now filled with seeds inside the greenhouse. Greenhouse growing. The greenhouse environment is carefully controlled. Temperature, humidity, and light levels are monitored 24/7 using computer systems. LED grow lights supplement natural sunlight, and misting systems maintain optimal moisture levels. After 7 weeks in the nursery, the seedlings are ready for transplanting. During this time, they've developed strong root systems and multiple sets of true leaves. Workers inspect each tray, removing any weak or diseased seedlings to ensure only the healthiest plants make it to the field. Transplanting to the field. A machine automatically plants the seedlings into the soil, where they receive daily care and grow tall, resembling a 5 to 6-year-old child. These transplanting machines are engineering marvels. They can plant up to 10,000 seedlings per hour. The machine creates a small furrow, places a seedling at the correct depth, packs soil around the roots, and applies a measured amount of water, all in one smooth motion. Workers ride on the machine, feeding seedlings into the planting mechanism and ensuring proper placement. Field management. Over the next several weeks, farmers monitor their fields daily. They apply fertilizers based on soil tests, ensuring plants receive the right balance of nitrogen, phosphorus, and potassium. Irrigation systems water the crops during dry periods, and pest management specialists watch for signs of insects or disease. Tobacco plants are susceptible to various pests, including hornworms, aphids, and wireworms. Modern farmers use integrated pest management strategies, combining biological controls, targeted pesticides, and crop rotation to protect their plants while minimizing environmental impact. Topping and suckering. In July, tobacco plants begin flowering, prompting farmers to drive cutting machines across the fields to remove the tops of plants, maximizing nutrient concentration in the leaves. This process, called topping, prevents the plant from producing flowers and seeds. By stopping reproductive growth, the plant redirects all its energy into leaf production, creating larger, more flavorful leaves with higher nicotine content. Farmers simultaneously spray growth inhibitors on the plants. These growth inhibitors, called sucker control agents, prevent the growth of side shoots called suckers. Without these chemicals, workers would need to manually remove suckers multiple times throughout the growing season, a labor-intensive and expensive process. Harvest timing. After a month, the tobacco plants turn yellow, indicating they're ready for harvesting. This color change signals that the leaves have reached peak maturity. The chlorophyll breaks down, revealing yellow and golden hues underneath, a sign that sugars and other compounds have developed fully. Experienced farmers can determine harvest readiness by feeling the leaves. Mature leaves have a slightly leathery texture and snap cleanly when bent. Timing is critical. Harvest too early, and leaves lack flavor. Harvest too late, and they become brittle and damaged. Mechanical harvesting. A digging machine digs deep into the soil, lifting the plants and transferring them to bins on trucks. Modern harvesting machines are incredible pieces of equipment. They use hydraulic blades to cut beneath the root system, mechanical arms to lift entire plants, and conveyor systems to transfer them to collection bins, all while moving to the field at a steady pace. This year's weather is relatively favorable, so farmers have a good harvest. Weather plays a crucial role in tobacco quality. Too much rain dilutes flavor compounds, while drought stresses plants and reduces yields. This season's balanced rainfall and sunshine have produced robust plants with excellent leaf quality. Once the bins are full, all the plants are moved to another truck, concluding a day of harvesting and returning to the warehouse for the drying process. Harvest crews work long days during the harvest season, which typically lasts 4 to 6 weeks. Coordination is essential. Harvesting, transportation, and drying must be synchronized to prevent leaves from spoiling. Drying priorities initial processing. The leaves on the truck are poured onto a conveyor belt. Workers quickly sort through the plants, removing any damaged or diseased leaves that could affect the final product quality. Dried tobacco leaves fall into the large chain container. This container is part of a continuous handling system that moves tobacco through various stages of drying. The system is designed to handle tons of fresh tobacco daily, without damaging the delicate leaves. Curing methods. After being moved to the storage room, wood is burned under the floor to create heat for drying. This traditional method, called flue curing, has been refined over centuries. The curing process is actually a complex series of chemical and physical changes. Temperature and humidity must be carefully controlled to allow chlorophyll to break down, starches to convert to sugars, and proteins to break down into amino acids, all of which contribute to tobacco's final flavor and aroma. Modern curing barns use computerized systems to maintain precise temperature and humidity levels throughout the curing process. Sensors monitor conditions in real time, and automated vents adjust airflow to ensure even drying. This process usually takes 5 to 8 weeks before the leaves are transferred to the cigarette factory. During this time, the tobacco's moisture content drops from about 80% to 10 to 15%, and its color changes from green to golden yellow or orange-brown, depending on the variety. Different tobacco types require different curing methods. Flue-cured tobacco, used in most cigarettes, is cured with indirect heat. Air-cured tobacco hangs in barns with natural ventilation. Fire-cured tobacco is exposed to smoke from smoldering with fires, giving it a distinctive flavor. Aging and fermentation. After initial curing, tobacco undergoes an aging process. The dried leaves are then transferred to a pressing machine to compress them into neat square bundles. These bundles, called hands, are stacked and stored in climate-controlled warehouses where they undergo slow fermentation. This aging process, which can last from several months to several years, allows flavors to mellow and develop complexity, similar to aging wine or whiskey. During fermentation, internal chemical reactions continue. Ammonia and other harsh compounds dissipate, while desirable flavor compounds develop. Temperature and humidity in the aging warehouses are carefully monitored to ensure proper fermentation without mold or spoilage. Energy transportation to processing plant. Tons of dried tobacco are sent to the processing plant, where the cigarette journey begins. Upon receiving raw tobacco leaves, quality control specialists inspect each shipment, checking for proper moisture content, color, aroma, and the absence of mold or damage. Large facilities can process over 100 million pounds tobacco annually. Trucks arrive throughout the day, and sophisticated logistics systems ensure smooth flow from receiving docks to processing lines. Sorting and grading. The first step in processing is sorting these leaves based on size, type, and quality. This sorting process combines human expertise with machine vision technology. Experienced tobacco graders can identify dozens of different leaf grades based on color, texture, size, and position on the original plant. Top quality leaves from the middle of the plant command premium prices. Automated sorting machines use cameras and sensors to analyze leaves at high speed. They measure color values, detect defects, and sort leaves into different grades with remarkable accuracy. However, human inspectors still play a crucial role, providing quality checks that machines can't match. Conditioning. Once sorted, overly dry leaves are lightly steamed or moistened to make them pliable. Conditioning is essential because dry tobacco leaves are brittle and would shatter during processing. Steam chambers or moisture application systems carefully rehydrate the leaves to optimal moisture levels, typically around 12 to 14%. The conditioning process must be precise. Too much moisture can cause mold growth, while too little leaves tobacco too brittle to process. Advanced moisture sensors ensure each batch reaches a perfect consistency. Stemming and threshing. Next, conditioned leaves are passed through a stripping machine to separate the tobacco leaves from the stalk. The central stem, or midrib, of tobacco leaves is woody and doesn't burn well, so it must be removed. Modern stemming machines use rollers and vacuum systems to separate leaf material from stems with minimal waste. The removed stems aren't discarded. They're processed into reconstituted tobacco sheet, which is used in cigarette blends. This maximizes yield and reduces waste, making the process more economically efficient and environmentally responsible. Expansion and enhancement. Some tobacco undergoes additional processing to enhance its properties. One common technique is puffing or expansion, where tobacco is rapidly heated and cooled, causing cells to expand like popcorn. This creates a lighter, more porous tobacco that burns more evenly and requires less material per cigarette. Flavorings and casing solutions may be applied at this stage. These carefully formulated mixtures can include sugars, humectants, and natural or artificial flavorings that contribute to the cigarette's final taste profile. The exact formulations are closely guarded trade secrets, unique to each brand. Blending. Once stripped, tobacco leaves are ready for blending, followed by cutting them into small pieces. The art and science of blending. Blending is where tobacco manufacturing becomes both art and science. Master blenders, with years of experience, create precise formulas that define each cigarette brand's unique character. A typical cigarette blend might contain tobacco from 5 or more different sources, each contributing specific characteristics. Virginia tobacco provides sweetness and light flavor. Burley tobacco adds body and strength. Oriental tobacco contributes aromatic complexity. And reconstituted tobacco sheet ensures consistency. Blenders must account for natural variations in tobacco crops. Just like wine vintages vary year to year, tobacco quality fluctuates based on weather, soil, and growing conditions. Expert blenders adjust formulas to maintain consistent product quality regardless of these variations. Cutting process. After blending, tobacco passes through cutting machines that reduce it to the perfect size for cigarettes. Different cut widths affect how the cigarette burns and tastes. Fine cuts burn faster and produce lighter smoke, while wider cuts burn slower and create more robust flavor. Modern cutting machines are precision instruments. They use sharp rotating blades to create uniform cuts, typically 0.5 to 1 millimeter wide. The tobacco then passes through screens that remove oversized pieces and fine dust, ensuring consistency. Final preparation. The cut tobacco is further dried to precise moisture levels, typically 12 to 13%. Specialized dryers use heated air to remove excess moisture, while sensors continuously monitor and adjust conditions. This step is crucial for proper cigarette manufacturing and storage stability. The cigarette manufacturing process is fast-paced and highly automated. Cigarette is the making machine. The manufacturing machine can produce up to 20,000 cigarettes per minute. These massive machines, often called makers, are engineering marvels worth millions of dollars. They stand several stories tall and stretch over 30 feet long, integrating dozens of processes into one continuous operation. A single factory might have 20 or more of these machines running 24 hours a day, 7 days a week. With proper maintenance, they can operate continuously for years, producing billions of cigarettes annually. Creating the tobacco rod. The process begins by creating a long tobacco rod, called a rod. Tobacco is fed from hoppers onto a moving belt. Precisely calibrated feeders ensure the correct amount of tobacco is distributed evenly. Too much tobacco makes cigarettes too tight to draw smoke through. Too little makes them burn too quickly and unevenly. As the tobacco moves along the belt, air jets and combs spread it into a uniform ribbon. This ribbon must be perfectly consistent in width and density. Variations of even a few milligrams can affect the cigarette's quality. Paper application. A roll of paper measuring up to 7,000 meters is spread out and a line of tobacco is placed. Cigarette paper is a specialized product, much thinner than regular paper, typically about 0.025 millimeters thick. It's made from flax or would pulp with additives that control burn rate. The paper includes tiny perforations that affect airflow and burning characteristics. These enormous paper rolls can weigh over 200 pounds and must be handled carefully to prevent tears or wrinkles. Automatic splicing systems join paper rolls seamlessly when one runs out, ensuring continuous operation. The rolling paper is then wrapped around the line of tobacco, forming a cigarette rod. This wrapping process happens at incredible speed. Forming rollers shape the paper around the tobacco, and a precisely applied line of adhesive seals the seam. The adhesive must be non-toxic, flavorless, and capable of creating a strong, durable seal. Quality sensors continuously monitor the rod's diameter, firmness, and uniformity. If any parameter falls outside acceptable ranges, the machine automatically adjusts or rejects defective sections. Cutting and filter attachment. The rod is cut into shorter lengths, and filters are attached to both ends. Rotating knife wheels cut the continuous tobacco rod into cigarette-length pieces, typically 84 millimeters long. These knives must be incredibly sharp and precisely aligned to create clean cuts without damaging the cigarettes. Filters are manufactured in a separate process. Cellulose acetate fibers, derived from a pulp, are formed into dense, cylindrical plugs. Some filters include activated charcoal or other materials that modify smoke characteristics. Tipping process. These filters are connected with tipping paper, a type of paper wrapped around the filter end of the cigarette. Tipping paper serves multiple functions. It provides a surface that's pleasant to put in your mouth. It holds the filter securely to the tobacco rod, and it often features branding, logos, or patterns that identify the cigarette brand. The tipping process uses hot melt or water-based adhesives applied in precise patterns. The paper wraps around both the filter and the end of the tobacco rod, creating a secure joint. Cork pattern tipping paper was originally used to hide lipstick stains, but has become a classic design element. Some cigarettes feature ventilation holes in the tipping paper. These tiny perforations, often invisible to the naked eye, allow air to mix with smoke when someone draws on the cigarette, diluting the smoke and reducing measured tar and nicotine levels. Quality control and pH into rigorous testing. The cigarette quality is rigorously controlled at every step. Quality control begins with raw materials and continues through every manufacturing stage. Automated systems check cigarette weight, length, circumference, firmness, and appearance. Laser sensors can detect microscopic defects invisible to the human eye. Sample cigarettes are pulled from production lines every few minutes for detailed testing. Laboratory technicians measure drawer resistance, how easy it is to pull air through the cigarette. They test burn characteristics, checking that cigarettes burn evenly without going out or burning too rapidly. Chemical analysis ensures nicotine, tar, and carbon monoxide levels meet specifications and regulatory requirements. Sophisticated instruments analyze smoke composition, measuring hundreds of different compounds. Taste panels, trained sensory evaluators, smoke sample cigarettes to assess flavor, aroma, and overall quality. These experts can detect subtle differences that instruments might miss, ensuring every cigarette meets brand standards. Primary packaging. Individual cigarettes are arranged into small groups and wrapped in foil to preserve freshness. The inner foil wrapper, typically made of aluminum-coated paper, serves as a moisture barrier. It prevents cigarettes from drying out and protects them from absorbing odors or humidity from the environment. High-speed packaging machines arrange exactly 20 cigarettes, or 10, 25, or other quantities, depending on the market, into precise formations. The cigarettes are nested together in a specific pattern that prevents movement and damage during handling. Secondary packaging. The packs are then assembled around the cigarettes and wrapped in protective film to preserve their aroma and freshness. Folding cart machines wrap cardboard boxes around the foil-wrapped cigarettes with incredible precision and speed. These machines can package hundreds of packs per minute, applying adhesive, folding flaps, and creating secure, attractive packages. The outer plastic wrapper, often made of oriented polypropylene film, provides additional protection against moisture and tampering. Heat sealing systems create airtight seals that keep cigarettes fresh for months. Health warning labels and tax stamps are applied during the packaging process. Different countries require different warnings, so packaging lines must be flexible enough to accommodate various regulatory requirements. Carton assembly. The packs are packaged in cartons or main boxes for transportation. Cartons typically contain 10 packs, arranged in 2 rows of 5. Robotic systems pick and place packs into cartons at high speed, and automated sealing systems close and seal the cartons. From cartons, products move to master cases, large corrugated boxes containing multiple cartons. These master cases are labeled with production codes, destination information, and handling instructions, then palletized for shipment to distribution centers and retailers worldwide. Environmental protection and U.S. waste management. Additionally, cigarette factories reduce environmental impact by employing advanced technology and efficient waste management. Modern tobacco facilities implement comprehensive recycling programs. Tobacco dust and trimmings are collected and processed into reconstituted tobacco sheet or sold for other uses. Paper waste is recycled, and even the wooden pallets used for shipping are refurbished or ground into mulch. Water and air quality. Water used in processing is treated in on-site facilities before discharge. Advanced filtration and biological treatment systems remove tobacco particles and chemicals, ensuring discharged water meets or exceeds environmental standards. Air quality control systems capture dust and odors from processing areas. High-efficiency particulate air filters and activated carbon scrubbers clean exhaust air before it's released into the atmosphere, minimizing impact on surrounding communities. Energy efficiency. Modern factories invest heavily in energy efficiency. LED lighting, high-efficiency motors, and heat recovery systems reduce energy consumption. Some facilities generate their own power, using cogeneration systems that produce both electricity and heat for processing. Solar panels and other renewable energy sources are increasingly common at tobacco facilities, helping reduce carbon footprints. Computer-controlled building management systems optimize heating, cooling, and ventilation, cutting energy waste. Sustainable sourcing. Many tobacco companies work with farmers to implement sustainable agricultural practices. Programs promote soil conservation, water management, biodiversity protection, and reduce pesticide use. These initiatives help ensure long-term viability of tobacco farming while minimizing environmental impact. Thanks for exploring the cigarette production process with us. From the carefully tended fields of North Carolina to the highly automated factory floors, cigarette manufacturing represents a fascinating intersection of agriculture, chemistry, and industrial engineering. We've witnessed how traditional farming practices combine with cutting-edge technology to create one of the world's most widely produced and controversial products. The journey from seed to finished product spans months and involves hundreds of steps, each carefully controlled to ensure consistency and quality. Thousands of workers, from farmers and warehouse operators to machine technicians and quality control specialists, play vital roles in this complex process. While cigarettes remain legal products consumed by millions worldwide, it's important to remember the serious health risks associated with smoking. The same sophisticated processes that create these products also make them highly addictive and dangerous to human health. If you're amazed by the blend of technology and craftsmanship we showcased, share, and comment your thoughts below. Have you learned something new today? What surprised you most about cigarette manufacturing? Let us know in the comments. We love hearing from our Captain Discovery community. Don't forget to subscribe to Factory Intelligence for more interesting journeys into the world of manufacturing, technology, and industry. Remember, this video is for educational purposes only and discourages cigarette use. If you or someone you know wants to quit smoking, resources are available through healthcare providers and organizations like the American Lung Association.